good to have you here this morning. So today we are going to change gears. We are stepping out of weather and into global climate change. And really going to talk about, is the climate changing? And if it is, why is it changing? All right, so here's the reality. First off, you talk about what climate is. Remember, weather is what's happening right now. So go outside. That's that's what's happening right now. What's the air temperature? What's the air pressure? What's the dew point? And how is that air interacting or coming together with other air and causing what's happening in the atmosphere to change, such as rain, snow, sleet, hail, dry, temperature-wise, clouds, and so on. So what is climate? Climate is the long-term weather patterns. It's the weather that's happening right now plus how it is over a large period of time. Really years, hundreds of years, thousands of years are the time frame. So climate's just what's happening over a long period of time. For instance, it might be cold in January, but the climate in Arkansas is a temperate zone. And temperate just means that it gets hot and cold, right? As well. Although some days it might be different. So we're looking at a big chunk of years. And really we're looking at the last 100 years, we're looking at the temperatures on Earth. And the scientific facts are the Earth's temperature is rising and has risen at an alarming rate, is a whole lot. And so today we're trying to ask some questions to try and figure out why is it? Why is it? So our first one we're going to deal with here is we're going to look at the sun. The sun causes thermal energy for the Earth to heat up. It's the main source of thermal energy on the Earth. Maybe the sun didn't. Maybe the sun has, for some reason, just given us more thermal energy than it has in the past. So that's our question, right? Has the energy from the sun changed over the last 100 years? So scientists do this. We take a look at it, right? And what we have is scientists who have gathered data over time. The yellow line here in this graph is for how much thermal energy the sun is radiating to the Earth, and the red line is temperature. And we look at our dates, 1880 to 2020. All right, if you look at it, you can kind of see a couple things happen. The first off is the first part of our graph here. Not a whole lot. It's not a whole lot of changes. Very minimal changes on how much energy and how much temperatures are changing. However, after 1960, we're going to start to see a couple things change. First off, temperature really starts shooting up, right? And then the amount of thermal energy from the sun goes down slightly. So what that tells us is that no, the solar energy has been the same. That's not responsible for causing our temperatures to rise. All right. Okay. So that's not it. What's next? So if it's not the sun, what else could be? So we stop and think, well, volcanoes, right? Volcanic activity gives off super hot melted rock, lots of heat, and a lot of gas. So maybe that has something to do with causing. So maybe we can say, hey, volcanoes right there. See it down there? It did it. And you see there's a volcanic blast. So again, as scientists, we look at our data from experiments to see what's happening. And if you look at our data, you can just notice that this is the Earth's global surface temperature, and it is increasing, like you saw in the previous graph. What they've done though is they've told us when the major volcanic eruptions have been. And if you look at all three of these, you'll notice there's something they all have in common, is they all have a lower temperature. When these earthquakes happened, there was a lower temperature. Temperature drops, temperature drops, temperature drops. So the answer is no. Volcanic activity has not really changed much over 100 years. And if it did, actually, it wouldn't matter because volcanic activity actually drops thermal energy. So the dust and debris that gets kicked really high up into the atmosphere, it sits around the atmosphere for months to years, mattering how large the earthquake for the volcano is, blocks the thermal energy from getting to the surface. So actually our temperatures actually go down. So it's definitely, it's not the sun, it's not volcanoes. Okay, so what else could it be? So idea 3 is, what about carbon dioxide? You hear that all the time, greenhouse gases, carbon, what's going on. By the way, when people talk about carbon like too much carbon in the atmosphere or carbon footprint or get rid of stop using so much carbon. They're really saying carbon dioxide. This gas that is a waste product from burning things, from our body processes. Remember back to when we talked about the human body. So maybe carbon did it. So maybe we point the finger. Carbon is the one that did it. So again, we take that question. We will go to try and find an answer. All right, and we have a graph right here. So has more carbon dioxide changed over the last 100 years? And the answer is yes. You also notice that as this carbon, this red line goes up, temperature has gone up right with it, right with it. And in the past 100 plus years, definitely we've seen an increase in carbon. So yeah, carbon did it, right? Yes. However, as a good scientist, we always want to ask another question, and that's the thing to remember is that science is not about asking a good question, getting an answer, and then okay, I'm done. Now I can move on to something else. There's a continual process of learning and trying to understanding how and why does this happen. All right, so maybe our next question is, okay, carbon is raising Earth's temperatures, but is this just normal? Is this a normal process, a normal cycle, all right, of the Earth? Did time do it? Did just the sake of time make the Earth heat up, and then it eventually is going to go back down? So let's look at another graph, more data, and this data is interesting. Look at how old it is. All right, we're talking 800,000 years. So this is the type of time that geologists take to study and people to study climate, climatologists to study large, huge amounts of time. Now, we obviously didn't have thermometers that long ago. This information is taken from ice core samples, from rock samples, possibly, I mean, some of more recent living matter as well, to see what happens. We notice that we see that same issue with temperature and carbon dioxide. They are linked step and step. But if you look, we can see there is a pattern, that you have highs and then lows, and then highs and then lows. So you have your high and then lows, and eventually the Earth's going to heat back up and get more carbon and then drop down. Carbon levels are changing constantly, all right, up to towards present time. This graph, however, does stop before our current time, and we'll see another graph that's going to show this. So the answer is yes. It kind of shows a pattern. Kind of shows a pattern as we go through. So the answer is yes, right? There seems to be a pattern. However, are we sure that this pattern is natural? Are we sure that there's not something different? So we need to look at a graph that's not as specific. Is it us? Did we do it? There's something about what we're doing as humans here on Earth that's not part of the natural cycle that's happened, right, over the last 800,000 years, according to the recent graph we looked at. So we'll take a look at our next graph. Now this is a very similar graph, very similar to that, except what we did here is we took a look at just the last 1,000 years, and then the very specific last 100 years plus, almost 200 years. And that's what these colors are for. This red dot here is this spot right here. So we look a little closer, we can see that even though the temperature has been rising, it has been kicking up big time. So this blue line here is this increase here, and this black line here in the last really 50 years, even higher. Now I want you to notice something. This is the level at which the highest level of carbon gets made. So not only is this really not really part of a cycle, because we've been doing some stuff that's never happened on Earth before, but look how much higher it's gone. Look how much higher it's gone. Okay, we were getting to about 300. Now we're pushing almost 4, almost 4. And so what this really points us, okay, what have we been doing the last 150, 200 years, 100 plus years? And really that is industrial revolution. And that's what this sentence here is that one of the changes really happened is the industrial revolution, which is when we started making stuff using fossil fuels, burning coal, natural gas, petroleum, and living our lives the way we think of. And really think about how much you rely on gasoline. You might notice the gas prices are really, really low, and you're just not driving many places because of our social distancing. But think of everything that's gotten to you: your food, your electricity, electricity to run the internet, electricity to run your device, um, everything that we have and move, including food. How does the food get to you? It's driven by cars, planes, trains, um, but and boats as well in some places. So this is a really good question here, right? How have we been involved? And the data really points us to that there's something going on. And the problem is that if we get carbon this high, is the Earth cycles high, low? Is it going to be able to bring these temperatures back down? And we don't know because it's never been this high, and we've never had man-made human responses to this. And this is why it's important for us to ask good clarifying questions, right? And it lets us answer questions, right? Right now, our best explanation based on our data, based on our good questions and our experiments is the use of fossil fuels over the last 100 years has caused carbon dioxide levels to rise, which traps heat and causes the Earth's temperature to rise. And we're not sure if the Earth's process is going to be able to correct, is going to correct this. Now, why? How do we know this? Well, we know it's because of good questions, and we just need to continue good questions. So as you look at this explanation right now, based on the good questions that we and other scientists have had, I want you to think, what other questions do you have? Are there other questions? Is there other things that could be causing these temperatures rise? All right. So think about what we know and how you can explain it, and always asking good questions, which is the basis, hopefully, of everything that we're doing in science classes. All right, so good job. Keep asking good questions. And if you have some good ones, write them down. And shoot some of those to your teachers, to your teacher, and maybe other classmates as well. All right, keep asking good questions.